Okay. Hey guys, we have several goals today. One is to find distance. Okay, Zach, TJ. Distance between 2 points in a coordinate plane. If you need to graph the points so you can see things better, then do that. We are going to determine if a triangle is isosceles, scalene, or equilateral by looking at the lengths of the sides. Now, the last class, they didn't remember what those words meant, so we're going to review that as well. We're going to write the equation of a circle, and we're going to find the center and radius of a circle given the equation. And that's very important for future classes. Actually, all of this is important. Okay, Zach? Okay, ready? Now, I want to find the distance between these 2 points. Well, the shortest distance is a straight line. And you could just graph this and do some counting. Okay, Sydney, TJ, I need you focused here. I'm going to draw a triangle because then I can use Pythagorean's theorem. Now, the problem is you have to look at this carefully. These are the x coordinates. So this length is the distance on the x-axis. So if you're at -1 and you move all the way over to +6, how many squares have you moved? 7. Now, you could take 6 minus a -1 and do it that way, but that seems like a lot of work. I'm not going to have you do that. Some of you will choose to do it, but I'll show you where the pitfalls are. Okay, now let's look at the y's. And the y's are this distance. Okay, TJ, what are the y's? How far is that? 5. Okay, it's 2 down here, but 3 up. It started at -2 degrees, went to 3 degrees. That's a total of 5 degrees. I don't care about the sign. I want to keep it positive because I'm really talking about distance. Then we're going to use Pythagorean's theorem. Yes? Yeah. Well, call that D. D squared equals 7 squared plus 5 squared. So D squared, what? TJ? Cole, I think you need to move over there. Okay, Sydney, question. Because you start at -2, it's 2 degrees below 0, and you go up to 3. You just have to keep the x's and y's separate. And I'll show you how I do that. Okay, but now once we get our triangle, it's Pythagorean's theorem. So it's 7 squared plus 5 squared, and that's 49 plus 25. And I think Curran told me that this is 74. And then we do what? No, this is the square of the distance. Square root of. Yeah. Or you could go to your calculator and find it. There's no... There's really no reason to simplify it. But be careful if you're going to use calculators and things. So be careful how you do that. And that's all the distance formula is. It's basically creating a triangle. I'm going to give you the formula. We're going to look at it. That's the next slide. Well, I guess not. Oh, yeah, it is. So we're going to draw this and create a triangle. Now, how do I know what this distance is? Well, it's the distance between x1 and x2. If you are traveling, you are at mile marker 10, and then you go to mile marker 15. How many miles have you traveled? 5. How did you get that? You subtracted them. That's how you find your distance. So I have to subtract these. It doesn't matter what the order is. I do want a distance, so I'm going to put it in absolute value. x1 minus x2, although that will be irrelevant shortly. But honestly, that is the distance there. You can do x2 minus x1. Slope, it matters on order. Distance, it doesn't. I just want a positive number, so I put it in absolute value. What about this distance? What's that distance? I'm looking at the y values now. How far apart are they? You're just going to subtract them, just like we did before. So y1 minus y2, and I'm going to make sure it's positive, so I'll put it in absolute value. But it's going to be irrelevant. Okay, Zach? It's not going to matter because we're going to use Pythagorean's theorem. And this d squared, is equal to this length squared. Now, what happens if you square a negative number? You get positive. But I really don't care about the absolute value. If I get a negative number there, big deal. I'm going to square it anyway. So it's going to become positive. Plus, that's not what I want to do. Okay, plus y1 minus y2 squared. So what's d? It's equal to the square root of this. That is distance formula. But honestly, I'm not going to use it. Because the problem comes in when you use it. You have problems with the negative signs. So, here's what you tend to do. I'm going to go back to the previous problem if you're ready. Oh, thank you. Yeah. It's just, but you know what? It's just Pythagorean's theorem. That's all it is. Yeah, I know, it's a chord. There. Okay, here's the problem with using the formula. Okay, guys? I have to do subtraction of the x's. This is what I see students doing. I've done this for years. You do that, and you write it that way. Plus, etc. That's totally wrong. You can't do that. You must have parentheses here. So let's not do it. Just look at the x's. How far apart are they? They're 7. Okay, let's do another problem. Oh. I just showed you why I don't use distance formula. I just go, how far apart are those? How far apart are the y's? So I'm not going to use the distance formula. It's just Pythagorean's theorem. Okay, let's try a problem. Okay. Now, I'm not going to use the distance formula. I'm just going to do the problem. Now, how I do the problem is I write down 8 and 15 and negative 7 and 23. By the way, another way to write distance here is that's the change in the x values. Guys, Zach, you're not going to know how to do this. And that's the change in the y squared. That's another way to write the formula. x1 minus x2 is the change in the x values. y1 minus y2 is the change in the y values. Okay. I am not going to use that formula. I'm kind of going to do this one. So d is equal to the square root of, and then you look at the x's. Now be careful. Think. It's 7 that way and 8 that way. What's the total distance between those points? 15. You don't show the substitution. This works. I train teachers. I go all over the country and train teachers, and I show them this because now you're not going to make the mistake of doing 8 minus a negative 7 squared, writing it that way because it's just plain wrong. You must have the parentheses. Besides that, that's hard. This is easy. How far apart are 15 and 23? 8. That was easy. Now, if you're really clever, you could do the work, or you can recognize this. C squared equals 15 squared plus 8 squared. Look behind me on the board. I have the 2 legs, 8 and 15. So guess what the hypotenuse is? It's 17. Well, let's do it. So you believe me. This is a Pythagorean, Zach, this is a Pythagorean triple. 8, 15, 17. I can do it, but it's always going to be this. But let's do this once. So if you don't want to know the triples, you don't have to. You can always use Pythagorean's theorem. 15 squared is 225. 8 squared is 64. So that's the square root of 289. And what's the square root of 289? I hoped to recognize the triples, because then I don't have to do any of this work. I don't want to do it. Zach.
So isn't that just kind of like this distance formula?
It is. Distance formula and Pythagorean's theorem are the same things. So really, I mean, you could draw the triangle. Have you done distance formula in the past? But you probably were forced to do the substitution. Don't do the substitution. It's too hard. Let's try another one. Ready? Now, I want to find the perimeter of this triangle. Sometimes it helps me to draw the picture. I'm going to label these points A, B, and C because it's easier. Let's see if I can do a better job of drawing this. A is at 1020, about. B is at 1316. It's not going to be accurate, you guys. It's okay. C is at 1222. Okay. I want the perimeter of this triangle. So guess what? I have to find the distance between A and B, the distance between B and C, and the distance between A and C. Did the picture help figure out what I have to do? I really want to know if it's a equilateral isosceles scaling. But the picture, when I do the picture, I want to find all the lengths of all these sides. So I'm going to write A is 1020, B is 1316, C is 1222. Okay? So I want to find the distance between A and B. How far apart is 10 and 13? All right. So it's the square root of, well, you got to square it. 3 squared is 9. So this is easy. If you do it my way, it's easy. Now, how far apart are these guys? 4. Oh, I recognize something. So that's 16. Or you could have said 3 squared plus 4 squared, because then I recognize that triple. 3, 4, 5. You know it's 25. Is that okay? You see what I'm doing? Now I want to find BC. How far apart are these? 13 minus 12 is, well, I could do it. 1 squared plus. This one's not going to be a triple. I don't see a 1 up there, unfortunately. Unfortunately, it's not going to work. 16 to 22, how far? 6. Can you do that in your head? What's 36 plus 1?
37.
Square root of 37. Well, obviously they're not the same. And you know what? I don't care if you use a calculator or not. I probably won't. Now, AC means I've got to go from this one to this one. How far apart is that? So it's 2 squared plus, and this is 20 and 22. Oh, it's 2, right? Now, in the past, you probably had to show the substitution. It was a lot of work. If you don't show the substitution, it's much faster, and you're much more accurate, and you're not going to make the sign mistakes and the parentheses mistake. This is the square root of what? 8. So the perimeter is 5 plus the square root of 37, which is about 6, right? If you care, plus the square root of 8, which is pretty close to the square root of 9, which is approximately 3. I'm just fine with that. When you've taught the upper level classes and you know what's required and what's not required, it's not required to do anything with those radicals. So don't even bother. It's a waste of time. Because you're just going to put it on your calculator. Let's be real. We used to simplify square root of 8, make it 2 square root of 2. Well, that's because we had slide rules. We don't have slide rules. We have calculators today. There's no reason to do it. There are reasons to do things like that, but you don't need to know that yet, so there's no point in doing it yet. Okay, do you remember what these words mean? Equilateral. All three sides are equal. They don't look equal to me. Isosceles. What's isosceles?
Two sides are equal.
At least two sides are equal. So actually that's an isosceles triangle too. So I don't have two sides equal either, and scalene is no sides equal. So which one is this? Scalene. So in a sense, we're reviewing also for your final exam by throwing some of this stuff in here. Okay, are you ready? I'm going to help you, but I'm going to walk around and have you guys do it. X is 2, -2. Y is, and if you want to graph it, you can. Now, does it help? You'll see it written vertically. It helps me. Because I want to find the lengths of all these sides. So I got to find X, Y. I have to find Y, Z. And what's the third one? XC. And then I can tell if it's scalene, isosceles, or equilateral. There should be a comma here. So to do XY, it's the square root of, okay, what's the distance there, 2 to 13? Should be doing this. Especially not in this class. 2 to 13. No, 11. So that's 11 squared plus. And then I got to do this. -2 to -4. How far apart are they? 2. Is this not easy? If you do it this way, if you did it with distance formula, it would be hard. I won't even show it to you because I don't like it. That's it. What's 11 squared? 121 plus 4. So it's the square root of 125. Okay, I'm going to pause my recording and have you guys find the other ones. There we go. Now I'm going to walk around and help you. Okay? Some of you are still insisting on using distance formula. Okay, Eve, try this. YZ, shh, you guys, is this one. How far apart are 13 and 8? In other words, think of it this way. It was 8 degrees, and it got up to 13 degrees. How many degrees did it change? That's right. 5 squared plus. Now, some of you aren't doing the squares. Some of you aren't doing the square roots. You got to do all of this. Now, how far apart is this? It's 4 below Sydney, and it goes up to 6. How many degrees did that change? 10. So that's 25 plus 100, which is 125. Now, let's do YZ. No, XZ, I'm sorry. 2 to 8 is how many? What's the difference there? 6. So that equals the square root of 6 squared plus, and how far apart are these? -2, that's 8. See, it's so much easier if you don't use the distance formula. Just find out how far apart they are. You are subtracting, but, and if you have troubles with it, think of temperatures. Now, I know that the answer here is 10, because you know what? This is a 3, 4, 5 triangle. Now, let me remind you about these Pythagorean triples, TJ. If 3, 4, 5 works, then any multiple of that, even if it's a multiple by a half. But if I double this, and double that, and double that, that's also Pythagorean triple. If I triple 3, which would give me 9, and I do 4 times 3 gives me 12, I do 5 times 3 gives me 15, that's another triple. So I recognize this as a 3, 4, 5 triangle. It's just doubled, that's all. So the answer is 10. Can you use Pythagorean's theorem and just use a calculator? Sure. Okay. Last but not least, the equations of circles. Okay, you need to pay attention because it's a little tricky. Once you get it, you'll be okay. The formula for equation of a circle is right there. Where does it come from? Well, a circle by definition is the set of all points that are the same distance from a given point, called the center. They're all equidistant. So I'm going to put my radius in here. There's the center. That ordered pair is h and k. It's a constant. Any point on the circle is x and y. And I'm going to use Pythagorean's theorem. So r squared equals, now, I want this distance. If you're at h and you go to x, how am I going to find out how far that is? If you were at mile marker 10 and you go to mile marker 15, you told me it's 5. What do you do with those two numbers? You subtract. So I'm going to do the same thing here. You could do h minus x. It doesn't matter. I like to have the x's first. So it's x minus the x coordinate here, h squared. It's just Pythagorean's theorem. This distance is y minus the k. And this is x minus h. And that's the formula for a circle. You are going to run into this in many classes following this. It's part of a conic section. And why are they called conic sections? Because you think of that as a cone. Guess what? That's only half of a cone. This is a full cone. You didn't know that, did you? Now, if I take my knife and I slice it like this, that cross section looks like that, and that's a circle. That's why they're called conic sections. If you slice it, more than you want to know, if you slice the plane this way, you get a squished circle, which is called an ellipse. And if you slice it this way, you get what we call a hyperbola. It looks like this. And you will study those later on. Right now, circles are the most important ones. I believe they're on the ACT. So, that's all there is. How do you do a problem? Here's the problem. I'm going to rewrite it. This is x plus 2 squared plus y minus 5 squared equals 36. And now, underneath it, I'm going to put the formula for the area for a circle. It's x minus h squared plus y minus k squared equals r squared. I like to do easy things first. That's the easy thing. Those things are equal. So r squared equals 36. What's the radius then? That's the formula for a circle. It's Pythagorean system. Right? Pythagorean's theorem. If I square root this, what's r equal to? You guys know this one. What's the square root of 36? 6. Easy one. Well, I don't know. Maybe the y is even easier. These match. Guess what? These match. What's k equal to? What do you think? Sydney? What's k? DJ, can you help her out? If this is y, and this is minus, and they match, and this is 5, and that's k, what's k? 5. Now, the problem with the next one, the first one, is it doesn't match. This is x. That's a good match. But that's not. That's not. I need x minus. Can I write x plus 2 differently? Can I write it this way? If I write it this way, TJ, what do I have to put in there to make it equal to that? A negative 2. That's my h. H is negative 2. Some of you will say, well, this is a negative 5, it's the opposite. That's a positive 2, it's the opposite. That's true. Another way to look at it is you look at what makes that 0. Negative 2, what makes that 0? 5. Can you write the equation of a circle if you're given the center 2, negative 4, and the radius is 7? TJ, how am I going to do that? There's the formula. It's x minus something squared plus y minus something squared equals the radius squared. So that's h, that's h. That's k, that's k. And this is going to be r. H is, remember, you have to get the right order here. This is H and this is K. Again, it's alphabetical. So H is what? Not 4. -4, TJ. It's what? It's 2. K is, what's K? -4. Do I care if you simplify that? Not really. And what's R? 7. It's good enough for me, but if you want to clean it up and make it look nice and pretty, you would write this. X minus 2, you will get full credit for this line, by the way, plus, and it's y plus 4 squared equals, what's 7 squared? I know it, because the radius is 7.
What is 2 and 4?
That's the center of the circle. That's the x coordinate, that's the y coordinate. It's alphabetical. What's 7 squared? Yeah. This is a squared plus b squared equals c squared. In a circle, you get a right triangle. You could have actually drawn the picture. Where were we? We're at 2, -4. I'll set it backwards. That's 2, -4. My radius is 7. So that's 7. And there's x, y. So this length here is x minus 2. I think this is harder. This length here on the y's is y minus a -4. Pythagorean's theorem says that side squared plus that side squared equals that side squared. It's all Pythagorean theorem. I could have just said a squared plus b squared is c squared and given you all this time to do the homework, because that's all it is. It's Pythagorean theorem. So this is an important formula to remember, the equation of a circle. But it's just Pythagorean theorem. Now, how about any homework questions? I think there are some. In particular, I'm thinking of that one, number 17, might have been hard. What about number 8? I know some of you asked me questions. What about the rest of you? Did you guys get number 8? Oh, we can do that. We're going to complete this rectangle so that I have a right triangle here. I need to know all the sides. Now, this is a square. So if this side's 15, how big is this side? 15. So how big is this side? 15. So I have this little triangle here. That's 15. Sorry, my picture's pretty bad. Well, unfortunately, this is up to here is 15. I need to know what that is. But I can figure it out because this area is 25. So how big is each side? 5. Because 5 times 5 is 25. Well, if this is 5, then this is 5. So I get a triangle that's 20. This side's 15. And I want the diagonal. Now, it's a Pythagorean triple. How do I know? Divide 20 and 15 by a common factor. What goes into both 20 and 15? 5. So my triangle reduces. This new triangle would be 4 and 3. What would this side be? 5. Okay, I got to get back, though, to the original one. This can't be 5. This was 15. This triangle's 5 times bigger than that. So what do you have to do with the 5 here to get back to this? Multiply by 5. Now, can you use Pythagorean's theorem? Sure. I don't care. You said which other one? Oh, I think I know which one that is. Oh, no. 14. Oh, we have an isosceles triangle. Did you draw a picture? Oh, I can't do it without drawing a picture. Okay. 14 is hard because you have not done congruent triangles, so there's something you don't know. You might guess it's true. This is 6, and this is 8. How do you find the area? What's the formula for the area of a triangle? 1/2 base times height. TJ, how am I going to find the numbers here? TJ, what's the base? What's the height? Nope. Nope. You have to draw the height in. And the height is always perpendicular, which we've talked about. You should know it. But what you don't know is that it bisects this side. So this is 4. So there's h. So 4 squared plus h squared equals 6 squared. Can you find h? Yes. 16 plus h squared equals 36. And if you subtract 16 from both sides, h squared equals 20. So h equals the square root of 20. My answer is exact. Half of 8 is 4, so it's 4 square root of 20. You could simplify that square root of 20. I don't really care. Or you could change it to a decimal. I don't care about that either. I couldn't do the problem, so I drew the picture. And you don't really know that about the altitude of a triangle. What about, now I did a problem like that, so try that. What about number 17? Yes. I looked at 17, and I go, well, I don't know what's wrong with the picture. What am I going to do to figure out what's wrong with the picture? Okay, girls? Number 17, did you get that one? What'd you do? How'd you solve it? Well, you know what I did? Because the whole unit is about Pythagorean theorem. I said, I'm going to make it bigger. I am going to see if this is a right triangle, because I didn't know what else to do. So 3.75 squared plus 2 squared, is that equal to 4.25 squared?
No.
Actually, it is. Yeah, it is. I need a calculator. Although I don't know that. So I got my calculator out and I did it. Yeah, it's true. So this is a right triangle. Now, do you remember what happens in circles with right triangles? Right angle. That's half of the intercepted arc. So this arc has to be 180 degrees, which means this has to be a what part of a circle? It has to be a diameter. This has to be a semicircle. So this had to have gone through the center. That's what's wrong with the picture. But that's first off, you felt, well, what am I going to do? Well, I didn't know what to do, so I said, well, I'm going to find out if it's a right triangle. And if it wasn't a right triangle, then I'd say, I don't know what's wrong with the picture. That's all. Other questions or no? Because I'm tired of talking.